What if I told you you're already a time traveler? Not metaphorically, not philosophically, but physically, right now. And somewhere in the universe, time is moving so differently that someone could watch your entire life like a Netflix series. Today, we are not just asking, is time travel possible? We are asking something way more dangerous. Have we already done it? Without even realizing? Every movie, every sci-fi show, every conspiracy theory, they all treat time like a straight line. Past, present, future. Simple, right? Yeah, no, physics disagrees. Because according to Albert Einstein and his theory of relativity, time is not constant. Time is not even universal. And time can bend. Let's start with something that sounds almost fake, but it actually is 100% real. Astronauts on the International Space Station are actually traveling into the future. Not by years, not by days, but by milliseconds. Here's why. The faster you move, the slower time moves for you. This effect is called time dilation. So when astronauts orbit Earth at insane speeds, their clocks tick slightly slower. Their bodies age slightly less. Meanwhile, when they come back, they've already jumped into the future. So yeah, in a way, we have already built our first time machine. It's just really bad. Let me just mess with your brain for a second. Imagine this. You get on a spaceship, travel near the speed of light for 5 years, come back to Earth. 100 years have passed here. Your family gone. The world changed. But you still young. That's not sci-fi. That's physics. We think time flows like a river, but in general relativity, time is a part of something even more big. Space-time, a 4D fabric where space can bend. And time bends with it. At every moment, you're inside something called a light cone. Think of it like a spotlight pointing into the future, showing all the paths you can take. Normally, that cone points forward. But if space-time bends enough, then that cone also tilts. And if it tilts far enough, future can point into your past. This is where physics stops being comforting and starts being weird. Because Einstein's equations allow something called closed time-like curves, paths through space-time that loop back to themselves. Meaning, you move forward the entire time, but still somehow end up in the past. No reversing, no going back, just pure geometry. So now the question isn't, can we move forward in time? We already can. The real question is, can we go back? Because if we can, then somewhere a future human, a hidden experiment, or something even stranger might already be there. So we have established something insane. Time can slow down, time can stretch, and you can move into the future. But now we are stepping into a different question. Can you go back? Because if forward time travel is a glitch, backward time travel is a break in reality. Imagine folding a piece of paper. This is point A, let's say, and this is point B. Normally, you would travel across the surface. But what if, instead of doing that, you just punch a hole through it? That's a wormhole. At least in physics, these are called wormholes. They are solutions to Einstein's equations that connect two different places or two different times. Here's where it gets dangerous. If one end of the wormhole experiences time different than the other, you can create a time difference between the two ends. So one side is the present and the other side is the past. Walk in on one side, exit the other. And you have just traveled backwards in time. No machine. Just space-time geometry. But now let me give you a reality check. There's one problem. To keep a wormhole open, you need negative energy. Something that literally breaks the known laws of physics. We have seen only tiny bits of these things, the Casimir effect, but nowhere near enough to build anything real. But we have already actually seen this. So, it's a possibility. Now let's go somewhere even stranger. Black holes. Not the simple kind though. Spinning kind. These are described by something called the Kerr metric. It's actually called Kerr. Proposed by Roy Kerr. I'm just gonna call it Kerr here. When a black hole spins, it doesn't just pull space. It drags space-time with it. like stealing honey by a spoon. Now imagine this. Space is twisting and time is twisting with it. At extreme regions, directions start swapping roles. Meaning moving forward in space could mean moving backwards in time. There are regions according to math where time literally loops. But you'd have to enter a black hole, survive being stretched like a spaghetti, and somehow escape. So yeah, I think it's not that ideal. Now let me show you something even crazier. A universe where you don't even need machines. You don't need wormholes. You don't even need black holes. Just the universe itself. This comes from Kurt Gödel. He found a solution where the entire universe is rotating. If space-time rotates, light cones tilt more and more until eventually your future direction points to your past. Meaning you could travel in a straight line, keep moving forward, and end up in your past. No paradox making machine, by the way, just reality itself, because our universe doesn't seem to rotate like that, at least from everything we have already observed. So at this point, physics is basically saying, yeah, time travel might be possible. But then comes the problem. The one that breaks everything. Paradoxes. You go back in time and you stop your grandparents from meeting any which way possible, any which way. Maybe you kill one of them or just create a hindrance in their way. Then, if you stop your grandparents from meeting, how was your dad born or mom born, and how were you born exactly? Now, you were never really born, so you never go back. So they meet. So you're born, you go back. You see the problem, right? Physics has actually tried to fix this. The first option is Novikov's self-consistency principle, where you can go to the past, but you can't change anything. Everything you do already happened. But if you go back, your existence itself changes a lot. The air that you breathe changes a lot. There's another option. Many worlds interpretation. You go back, but create a new timeline. You can't change the past, so you branch into another one. But one of the greatest physicists ever, Sir Stephen Hawking, looked at all of this and basically said, nature probably won't allow it. He proposed something called the chronology protection. The idea was that the moment time loops try to form, quantum effects explode uncontrollably, destroying the time machine before it works. Almost like the universe has a built-in firewall. So here's where we are. The math allows it, the universe might prevent it, but then there's one more layer. Because what if time travel already happened? Every time we try and get close to time travel, the universe pushes it back. So here's the question no one likes to ask. What if time travel didn't fail? What if it already worked once? Back in 2000, someone appeared claiming that they were from the future. His name? John Titor. He said he came from the year 2036. His mission? To retrieve a computer needed to fix future systems. But here's what made people pause. He explained time travel using real physics ideas, talked about microscopic black holes, described timeline divergence similar to the many worlds interpretation. He predicted a civil war in the US, a global conflict, a fractured world. None of it happened because it revealed something important. People want time travel to be real. So much that a well-told story can feel like evidence. Then there are the visuals. The moments that make you pause and go, wait, what? For example, Chaplin Time Traveler. A woman in 1928 appears to be talking on a phone. Decades before phone existed, by the way. Another example would be the hipster time travel. A man in a 1940s photo wearing what looks like modern fashion. Or like the Mike Tyson iPhone conspiracy. A spectator at a 1995 fight holding what looks like a smartphone. See, our brains are pattern-making machines. We see something unfamiliar and we try to explain it to ourselves using what we know today. It's called the perception bias, not time travel. So, time travel actually sits in a very, very strange category. It's not just science, it's not just imagination, it's a question about reality itself. Because if time can bend, if causality can break, the future can influence the past, then time isn't what we think it is. And maybe we are not moving through time at all. Maybe time is moving through us.